So let's talk about the intersection of probability and the normal distribution, which is where we talk about Z, and also we'll introduce a little bit of the concept of P. So the first thing to think about is percentiles. And percentiles is probably something you learned about way back in grade school, where you got this idea of ranking against other people and like what percentile are you in, right? Whether it's on some sort of achievement test or for athletic purposes or whatever, kind of, what the percentile you're in. If you remember, if you're in the 80th percentile, then 80% of people are below you, right? And 20% are above you, right? And so a percentile tells us what percentage of responses. So if we're thinking about a particular variable, and in particular, if we're thinking about the variable in a histogram and a frequency distribution, what percentage of responses are below a certain value, and we can know what percentage of the values are above a certain value, and how many are even between the mean and a certain value, especially when, if you recall, the normal distribution, the mean, and the median are the same number. So we can tell the distance to the mean, or the number of answers, the number of responses, the percentage of responses between a particular value and the mean, because the mean and the median are the same number and it's the middle, right? And so we know the median, 50% are above, 50% are below. For the normal distribution, that's true of the mean as well. So let's try a couple, and we'll see what I'm talking about here. So for this particular value, right, we'll start here, this 80th percentile. What percentage of answers are below the 80th percentile answer, right? And so again, this is a histogram where we have the values, all the values of a particular variable are along the x-axis, and the frequency of response for each value is along the y-axis. So this 80th percentile is telling us that at that particular value of x, 80% of the responses are at that value or below. Which means that 20%, because all the responses are 100%, 20% are at that value or above. And then again, if the mean is equal to the median, then we know that 50% are above the median, 50% are below the median. So the percentage between the mean and this value that's at 80% would be 30%, right? This is this amount right inside of here. So again, if we're looking at the 25th percentile, the percentage of answers below this are 25%. The percentage of answers above it are 75% of those answers are above that value that lies at the 25th percentile. And how many are between the mean and the value? Well, 75 minus 50 would be 50%. And again, if we look at something, the 15th percentile, right? This value, negative 1.04, is less than the mean, which is 0. And 15% of all values are less than that. 35% are between that value and the mean. And then overall, 85% of all values, all responses are above this 15th percentile response. So that's percentiles and how they fit into this. The normal distribution takes advantage of our understanding of percentiles and our understanding of the probability distributions that go along with it. So in our normal distribution, and if we look at this is a normal distribution where the mean is mu. That's the Greek letter mu right there in the middle, stands for the mean, right? So the mean is right there in the middle, the mean, the median, and the mode all being the same in this normal distribution. And then sigma here indicates the population standard deviation. So 34.13% represents how many responses are between the mean and one standard deviation above the mean. If we double that, we see that about 68%, actually a little bit more than 68%, are between one standard deviation above the mean and one standard deviation below the mean. If we go a little bit further, we see that about 68% of all responses are between two standard deviations above and below the mean. That's the pink and the blue sections here. And the opposite of that is also interesting. So if about 68% are between 34%, and then if about 95% are between plus or minus two standard deviations above and below the mean, then if that's 95%, then 5% are above or below, so below -2 standard deviations, above +2 standard deviations, right? So this is these tails that we're talking about here, right? These are the tails of the mean. So about 2.5% of all responses are above 2 standard deviations above the mean. And about 2.5% of responses are below 2 standard deviations below the mean. So about 95% are between those two. And we're going to talk about why that's important. The Z distribution is just the normal distribution. It's just a way that we refer to the normal distribution. So Z is a particular test statistic that we use. And the Z is distributed normally by definition, is a normal distribution with a mean of 0 and a standard deviation of 1. So a Z of 1 falls right here, right? Because here is 0, 0 plus 1 standard deviation falls right here. So this is a Z of 1, this is a Z of 2, this is a Z of 3, Z of -1, Z of -2, and Z of -3. Right? And so now we can start to see the value of Z in terms of telling us where we lie on the normal distribution. And really, that's all that Z is. Z is about telling us where a value lies along the normal distribution. So if I tell you that the Z score is 0, then we know that Z is right here on the mean, and that's where it lies on the normal distribution. If I tell you that it has a Z score of 1, then I know that it lies 1 standard deviation above the mean right here. If I tell you it's a Z score of -2, then I know I'm talking about this value here that is -2 standard deviations away from the mean, right? So a Z score is just a way of telling us how many standard deviations away from the mean we are. That's all that information tells us. A Z score is how many standard deviations away from the mean a particular value is. The Z score is how many standard deviations away from the mean a particular value is. And then the sign of the Z score tells us whether we're above the mean or below the mean. Positive Z means above the mean, negative Z means below the mean. And then the Z score itself is how many standard deviations we are away from the mean.